Hi everyone. In this lecture, I will be talking about a very simple but a fundamental concept in finance, which is time value of money. Now we need to understand what is time value of money. Now, there are three terms here: time, value, and money. Now, in finance, whenever we use the term money, we mean cash flows. Now, these cash flows occur at different periods of time, and therefore, there is a question whether they are same in value. So, time value of money really looks into this particular question, and there are methods whereby perhaps you can put these cash flows in equivalent terms. But the question is that why do we need to make this adjustment? Let me give you a simple example. I give you a choice that either you accept rupees 100 today or you will get this after 1 year. Which one would you choose? So the choice is between these two. Maybe that you will say that it's a common sense that I would prefer 100 rupees today. And you may argue that you would like to take these 100 rupees to a restaurant or to a coffee shop and drink a hot coffee. Now, this attitudes of yours is really about preferring present consumption over future consumption. You may also argue that, look, even if I don't use it immediately, what is the guarantee that I will pay you 100 rupees after 1 year? And therefore, to avoid this risk, you would prefer 100 rupees today. This is your attitude towards risk aversion. Now, then there is a third possibility that you can put your 100 rupees today in savings account in a bank or in a fixed deposit of 1 year at an interest rate of say 6%. So what you may argue therefore is that 100 rupees today is not 100 rupees tomorrow because of investment opportunities available to you. So these are the three reasons. But the most important of these is investment opportunities. Because you can allocate your money in such a way that you may postpone your consumption for future and you can also consume at present. Risk aversion, of course, you can ask for from the investment opportunity that you would need higher rate of interest to adjust for the risk. This gives us another concept that when we say interest in finance, we also talk about required rate of return. Now, your required rate of return depends on your risk attitude. Now, this will consist of, as we will discuss much in detail later, this required rate of return it consists of two things. There is a risk-free rate, and generally government securities offer risk-free rate in the sense that we expect government not to default. So there is no risk of default. While in any other investment opportunity in the market, you have risk. There is possibility of default. Of course, it may differ in terms of degrees, but then there is risk of default. Therefore, For assuming that additional risk, you ask for risk premium. You ask more than the risk-free rate. So graphically, for example, this would be your risk-free rate, and then so after that you would require a risk premium. Now this one is your risk premium. So risk-free rate and risk premium. This we shall discuss in great detail in another lecture. Now, how do you adjust for time value of money? Now, there are two methods. One is compounding, which relates to future values. The second one is discounting, which of course is finding out the present value of your cash flows. So for example, if you have invested 100 rupees in a share, okay, or let's say a simpler example that you put this money in bank in a fixed deposit. Now the question is that what is its equivalent value after 1 year? As we said that this adjustment is done through interest rate. So you need to know interest rate here. So that is the question when we are compounding. In the case of discounting or present value, now let's assume that you receive 100 rupees after 1 year, and therefore the question which you are posing is that what is the present value of this money today? So when we say time value of money, when we talk about this value, really speaking, we are talking about this particular thing, that either if we can find out the future value or we can find out the present value. Let us talk in detail about future value. Now let's say that you put your money today. So we will put it in the form of a timeline. So it is 0 means today and then after 1 year. Now in order to get this future value after 1 year, what you need to know is the interest rate. Let's assume that this interest rate is 8%. Now therefore what you get is after 1 year you shall get back your 100 rupees, as well as you will get interest on 100 rupees. Okay, so you have your principal 100 plus your interest, and what you get as future value after 1 year is 108. Now here actually you could write this as, if you say 100 is common here, and you have 1 plus your interest rate here. So this is your amount today. Let's say that this is your amount today, A. Okay? And this one is your interest rate, say I. So you can write this as, this all can be expressed as future value after 1 year is equal to, either you may write present value or you may write it is your amount today and it will grow at this rate since it's 1 year, so raised to 1. Now let's assume that you pay 100 rupees today and this one is for, let's say, for 5 years. All right, this is for 5 years. Now what you are saying is that how much is your future value after 5 years? Now if you apply this formula, it's very simple. So your future value after 5 years would be, assuming once again that the interest rate remains as 8%, this will be the amount which you have deposited today into 1 plus 0.08 raised to 5. You can use scientific calculator to find out this value, to calculate this value, and then you will get the amount after 5 years. So really speaking, it's a simple to find out future value of any lump sum in future. Now, let's take another example, and that example is that instead of 1,000, let me say that this amount is 20,000. This amount is 20,000. So the present, now here, 1.08 raised to 5, if I use scientific calculator, this factor is 1.469. So after 5 years, you are going to get 29,386. Of course, your 100 rupees would be 146.9 after 5 years. Let us take another example, and this example is that, let me draw the timeline. So this is 0 period, this is 1, and you deposit 100 rupees here, then 100 rupees year 2, then in year 3 once again you deposit 100 rupees, year 4 you deposit 100 rupees. Now let me make an assumption that here the interest rate is 6%. How would you find out the value of these cash flows at the end of 4th year? Now, if we are saying that at the end of the 4th year, in that case, this 100 would remain 100. But then this amount will grow for 1 year. From year 3 to year 4, this will grow for 1 year. Now, if it grows for 1 year, it's 100 into 1.06 raised to 1. In this case, it remains 100 only, but of course, if you want to show it, it's 1.06 raised to 0, which means 1. And this is year 1. Now, this grows for 2 years, and therefore, your formula is 1.06 raised to 2. This grows to 3 years, and your formula is now, if you see 1.06, the factor is 1. So you have 1 into 1.00. Let me write 3 decimal points. In this case, this is 1, therefore it's 100 into 1.060. This is a square, 1 point, and then if I find out the square of 1.06, it's 1.126. This is raised to 3, and this comes as 1.191. So your future value today is what it is. There is no change because it's today. After 1 year, this becomes 106, and then after 2 years, this amount becomes 112.4, and this amount will be 119.1. The total amount which you get is 400. If you total that, 437.5. So 100 rupees deposited each year after 1 year for 4 years will accumulate to 437.5, sorry. Now, let us look at here. If I add this one, so if I add, this becomes 437.5. And if you, so this adds to this. And this amount is common. 100 is common. So really speaking, if you multiply 100 by this factor, you get this answer. So this factor is 4 point, it is, this one is 4.375. Okay, and when you multiply this by 100, you get this number. Now this one is called future value factor for annuity, or you can write it future value annuity factor, whatever way. Now in order to clarify the rate and the number of years, in this case the rate is 0.06 and it is for 4 years. So this is future value factor for annuity. This is annuity. When you receive same amount each year, it's called an annuity. Now this 4.375, you arrived at this number by finding this factor for each of the years and then adding. You can do it directly. There is a simple formula, and the formula is that if I say future value factor for annuity, and of course it's this one, now the simple formula for this is 1 plus I raised to n minus 1, and this is divided by I. Of course, this you will multiply by the amount of annuity, A. Let's call it A. Now we are not writing A0, A1, A2 because A1 is equal to A2 is equal to A3. Therefore, you may simply write A. So if you use a scientific calculator, you shall get this same number, 4.37. Let us take the same example, but here we shall make an assumption that your deposit starts from the very beginning. So this is year 0, that is today itself you put 100 rupees and then 100, then year 2 again 100, year 3, of course deposits are only 4, but then you would like to wait for 4 years because your deposit is for 4 years. In 4 years there is no investment because here you started after a year. In this case you started depositing from today itself. So in the same way you can calculate. Of course the calculations are already there. So if you do this, this is 1 year because you are waiting for 1 year, and for 1 year we found that this is the amount. So this amount will grow to this one. Now for 2 years the amount grows to 112.4. Now here the amount will go for 3 years, and for 3 years this is the amount. So you have 119.1. Now this amount will grow for full 4 years. Therefore, this time the factor is 1.06 raised to 4. And so here the factor is 1.06. Here the factor was 1.126. And here the factor was 1.191, but this time here your factor would be 1.262. So you get 126.2. So this is 1.06 raised to 1. This is 1.06 raised to 2. 1.06 raised to 3 and 1.06 raised to 4. So these are the factors. Of course, 4th year, because you didn't deposit anything, so there is no amount. Now if you add, this amount would be higher than this amount. And what you get is 463.7. If you add these factors together, so you will get 4.637. Now, why this has happened? Because you started earning on 100 rupees, which you deposited today, for 4 years. In the previous case, the first amount was deposited after 1 year, and therefore it could grow only for 3 years. Now this particular, when you have upfront deposit or payments, that is from the very beginning, it is called annuity due. So this is annuity due. This is simply called annuity. This example is of annuity, and this example is of annuity due. Now again, you can find out this factor easily using the same formula. Let me put this A here. A here. Now the simple formula will be, now this time I will write it future value factor for annuity, but I will write due, and the formula remains the same with one addition. 1 plus I raised to n minus 1 divided by I, but then this will be multiplied by 1 plus I. You will multiply this 1 plus I. Now this factor, this you have added because the amount started here from the very beginning. Notice that in these two examples, we have assumed amount to be the same. And in the first case, we said that this is annuity, and in the second case, we called it annuity due. The difference is that in case of annuity, the amount starts after 1 year. In the case of annuity due, it starts from the very beginning. Now, instead of 100 and 100 and 100 and 100 each year, you can change this amount. Maybe that you deposited 100 rupees in year 1, and then you may deposit 150 rupees in year 2. You don't have enough money to deposit in the bank in 3 years, and therefore you deposit only 50, and like that. There is no problem. In the same way, you will calculate your future value as you did here. And similarly, these factors will also be calculated in these factors will also be calculated in the same way. So really speaking, if you want to write it in the form of a formula, what you have is future value at the end of n year, and here you say that your amounts are different. Then you write A1 if it's after 1 year. If it's immediately, then you write A0. Now in this case, we generally would assume that it's after 1 year. If it's the case, then 1 plus interest rate raised to 1, because the deposit is for 1 year here. Now the second amount is A2, and this time it will be square. A3, and it would be 3. Now so on, depending on the number of years. So we can therefore write AN. N could be any number. It could be 3 years, 4 years, it could be 5 years, it could be 10 years. Your deposit may be for even 15 years. So we write AN into 1 plus I raised to N. So this will give you, so what you need to do, you need to know the amount and you need to know the interest rate. As I said, these can be different. That is, A is not equal to A is not equal to, A1 is not equal to A2. So these are not, for example, equal. They may be different. So they may be different. Or it is possible that they may be the same. In case you assume that these amounts are equal, say if you say that A1 is equal to A2 is equal to A3 is equal to let's say AN. Now this will be the case of annuity, and this will be case of annuity. Okay. Now if you deposit from the very beginning, that will be annuity due, and for that, as I showed you previously, there is a simple formula to use. Let us take an example of application of future value. Suppose you want to accumulate 25,000 rupees after 5 years at an interest rate of 5%. How much should you deposit each year? Each year, at the end, to receive accumulated amount, to receive rupees 25,000. So what you are trying to find out is that what is going to be annuity of 25,000 which you would like to receive after 5 years. So each year you have to deposit some amount. So if you go by annuity factor, so you can find out annuity factor. Let's take future value or compound value factor for annuity. In this case, your rate is 5% and number of years are 5. So if you use the formula for 1 rupee, actually, your formula is I raised to n minus 1 divided by I. So what you have is 1 plus, you have 1.05 raised to 5 minus 1 divided by 0.05. If you use a scientific calculator and there the function y raised to x, you can easily calculate this number. This comes equal to 5.252. What does this mean? This means that 1 rupee deposited every year for 5 years will accumulate this amount. Now it becomes a very simple second, third grade mathematics, that by depositing 1 rupee each year, you are able to accumulate 5.252. How much should you accumulate each year? How much should you deposit each year in order to get 25,000? So if you want to find this annuity, you want to find out this annuity, it is simply 25,000 divided by 5.252. So if you do that, approximately you must deposit 4,525 or 24 each year, and whose future value or accumulated value after 5 years will be 25,000. Okay. Now this problem is called sinking fund. Generally, companies, when they have to retire their bonds or debentures, they use this concept. So for example, I have to redeem bonds of 5 lakh rupees after 5 years. How much should I accumulate each year? How much should I put in a fund so that it accumulates to 5 lakh after 5 years. So that is called sinking fund. So actually from here, if you want to write it in the form of a formula, then you can easily write it this way. It is 1 divided by, and now you write that formula over here. So if you write your formula over here, 1 plus I raised to n minus 1 divided by I. So this is your factor for sinking fund. So you can create a sinking fund, multiply that by the amount, okay, and you get the future amount. Of course, this is the future value to which you want to accumulate. So you can easily get this particular answer. I will now discuss present value. Now let's look at this problem. I will receive 100 rupees after 1 year. So what I am trying to do is, what's its present value today? Again, I can do that if I know the interest rate. So let's say that this interest rate is, say, 10%. Now, this is future value, okay? So actually, if I write future value after 1 year, which is this 100 rupees, it's 100. And how did I get it? I got it, the amount which I deposited presently. I can write PV subscript 0, or I could have written just A, multiplied by 1 plus, in this case my interest rate is 10 raised to 1. So from here, if I want to solve for PV present value, this will come in the denominator, 100, 1.10 raised to 1. I can also write it as 100 into 1 divided by 1.1. Now I can find out this factor, 1 divided by 1.1. Now this is equal to 0.91 or 909. So present value of 100, which I receive after 1 year, is 90.9. In other words, you can say 90.9 at 10% will grow to 100 rupees after 1 year. This is the concept of present value. Let me say that I am expected to receive 100, not 100. This time let me say receive 500 rupees after 5 years. So what you can, after 5 years, but then I need to know the interest rate. And the interest rate is 10%. What you can say is that there is some present amount today which accumulates to 500 rupees after 5 years at 10%. So in the same way as we did here, we can write that my present value today is 500 divided by 1.1, and this time this will be raised to 5. 500 into 1 divided by 1 raised to 5. Now if you use a scientific calculator, this factor will work out 0.621. Therefore, the present value will be 500 multiplied by 6.21. Right? And if you multiply, as you can see it, this will be approximately 310 rupees. So once again, I can interpret it this way, that if I had 310 rupees, if I invest it at 10% for 5 years, it shall grow to 500. Same thing, if I have 500 rupees after 5 years, my interest rate is 10%. It is 310 today. Let's take another example. And this time let me draw a timeline. And these are my periods. Let me call them years. 1, 2, 3, and 4. Now, I deposit in a bank, let's say, or I receive from a bank or somewhere 100, 100, 100, and 100 each year. Now, if I know the interest rate, let me take interest rate once again at 10% for simplicity. You can take any rate. Now, in case of future value, what is my question? My question is, how much 100 will grow at the end of 4th year? How much this 100 after 2 years will grow at the end of 4th year? And similarly, in this case, what question I am asking is this: what is the present value of 100 rupees today, which I am going to receive after 1 year? And similarly, what is the present value of this 100, this 100, and this 100? Now, given our logic above, what we discussed, each time if I find out the present value factor at 10% for year 1, year 2, year 3, year 4, and then multiply by 100, I will get my answer. So let me do this. So actually what I have is 100 multiplied by, first, of course, I don't receive anything in year 0. So this is year 1 when I receive 100 into 1 divided by 1 plus interest rate raised to 1, and this factor is, as we had calculated even here, is 0.909. So what I will get for the first year is 90.9. Okay. The second year, 100 into 1 divided by 1.1 raised to 2 this time. Again, using a scientific calculator, I can work out this reciprocal of 1.1 raised to 2, and therefore I get 226 second year. Third year, the present value would be raised to 3. Again, this factor, if I use calculator, is 0.751. So I'm sorry, this will be 90 point, and this will be 82.6. This will be 75.1. Fourth year, it is 1 divided by 1 point raised to 4, 100 into 0.683, so I get 68.3. Now the total of this works out as 3016.9. Now here, if I add these factors, if I add them, now this total is 3.169. So if you go this long way, you get this 316. But if I knew this 3.169, I could have multiplied 100 by 3.169 and got the same answer. Okay. Now this number can be called as, now you see that these are same amounts each year. It's an annuity. And this number therefore is present value factor for an annuity. In this case, interest rate is 10% and the number of years are 4, and you can use a formula. Of course, you can derive that formula, but perhaps it's that you have to remember it. So 1 minus 1 divided by 1 plus I raised to n divided by I gives you present value factor for an annuity. Now, this can be again rewritten as, this is, if you really solve it, 1 divided by I minus 1 divided by I into 1 plus I raised to n. I generally use this formula because I find it easier to do. So in this case, we have 1 divided by 0.10, 0.1 into 1.10 raised to 4. And once again, if you use this formula, you will get again this factor. So in case of annuity, you simply need to use either this formula or this formula, multiply by annuity, and you will get your answer about the present value. Now here, I can change my question and I can say that 100 rupees occur today itself. So I will receive 100 today, 100 tomorrow, that is after 1 year, the 2 years and 3 years. And it's a 4 years period. Okay, from first year, it is 4-year period. What will happen in that case? Now in that case, what would happen is that if you get 100 rupees here, and then after this, then here, year 2, and then you get year 3, so your 4 year you don't receive anything. Okay, so once again in this case you will find the factors. Now 100 would remain 100. Okay, so here 100 would remain 100. Why? Because if you multiply that by the factor, so that factor will be 1 divided by 1 raised to 0. So 1 divided by 1.1 raised to 0 is 1, and therefore this amount will be 100. Now previously you have already calculated after 1 year the amount is 90.9. After 2 years, that again the amount which you calculated was 82.6, and here it was 75.1. Now if you add these numbers, so you get answer as 348.6. Okay, so this amount is higher than in the previous example. The reason being that you are getting 100 earlier in this case than in the first example. Now similarly, if you add all those factors, so the factors in this case are, if you add these 1.00, then you have 0.09, and then 0.826, 0.751. If you add these numbers, so you get 3.486. And again, if you multiply that by 100, this will be the number. Now, this is an example of annuity due. This is an example. This one is an example of annuity due. And this is present value factor. This one is present value factor of annuity due. So then if you want to write present value factor for annuity due, of course interest rate is this, years are 4. So this will be, if I use this formula, raised to n, now there will be an additional term, and the additional term is 1 plus I, because you get it earlier. Now, so again, if you apply this formula, 10%, 4 years, you will get 3.486. This is called annuity due. Now, in both these examples, these numbers can differ. Then you can't use these two formulae. Okay? So you receive 100, here you receive 120, here you receive 80, here you receive 50. So each time your amount is different, so you have to multiply that amount by the respective factor. So when we write present value, so really speaking, what we're doing is, it's my amount today raised to 1. If I start getting it from year 0, I will write raised to 0. This is A1, then this is A2, 1 plus I raised to 2. This was 1. And A3, 1 plus I raised to 3. This can go to any number. So AN divided by raised to N. So now A1 may not be equal to A2, may not be equal to A3, etc., etc. Or, so these are called uneven cash flows. Uneven cash flows. The procedure remains the same. There is no problem whatsoever. Each time you have to multiply by the factor. But if A1 is equal to A2 is equal to A3 is equal to, let's say, A9, A1N, now this is annuity. And for that you have annuity formula to use. Let us take an example. And the example is that you borrow 25, so you borrow rupees 25,000. Rupees 25,000. Okay? For 5 years. You borrow 25,000 for 5 years at 8%. Now, you are required to pay. So you receive 25,000 today, but then you require, so your payments, you have to pay payments each year for 5 years. How much will be your each year payment? So this is a problem of annuity. You have to calculate the annuity given the future value, given the present amount of 25,000. So in this case, what you are saying is that this 25,000 is equal to an annuity, and for that, because it's an annuity, therefore if you write the formula, 1 divided by I, which is 0.8, minus 1 divided by interest into 1 plus 8, 1.08 raised to 5. Now this will give you annuity factor. So what you have is, you have A and the annuity factor. If you calculate that annuity factor using your scientific calculator, okay, so you can calculate that factor. Now, if you use that factor and divide this 25,000, so your A will be 25,000, okay, now this will be divided by this factor, which is 1.08, 108 into 1.08 raised to this. Now this reciprocal of annuity comes to 0.25. So if you have 25,000 into 0.250, okay, so you determine your amount which is approximately 2060 or 61. This is your annuity. So each year for 5 years, you will have to pay 6,261 rupees in order to pay this amount in equal installment. So 25,000 is the amount which you receive today, and then you have to decide how much would be your amounts or payments each year over a period of 5 years.